Let P be a point not on the line L that passes through the points Q and R. Then the distance D from the point P to the line L is given by the magnitude of the cross product A cross B divided by the length of the vector A, where A is the vector that goes from Q to R and B the vector that goes from Q to P. Use this formula to find the distance from the point to the given line. Our point, P in this case, is going to be 4, 1, negative 2, while our line is given to us in parametric equations. X is 1 plus our parameter t, y is equal to 3 minus 2 times t, and z is 4 minus 3t. So we've got some point out here in space. We're calling that P, and that's at the coordinates 4, 1, negative 2. And then I've got some line that is, again, off of P. So P is not on that line, L, and it's going through a couple of points. Q is one point here, and R is the second point. Now we're looking for the distance from P to that line. That would be the distance from P to where I hit this line at a right angle. So the distance of this line segment is D, and we're going to form a couple of vectors. One is the vector which we're calling A from the point Q to the point R. So that's going to be this vector right here. The other is a vector which we're calling B that goes from the point Q to the point P. And so what I need then, the only thing I'm missing in this problem is some points Q and R. I need to find some points Q and R on my line, which again is given to me in terms of parametric equations. Well, that's pretty easy to do. I'm just going to let t take on a couple of different values. So for the point Q, I'm going to let t be equal to 0. And then x is equal to 1 plus 0, which is 1. Y is equal to 3 minus 2 times 0, which is 3. And z is equal to 4 minus 0, which is 4. So Q is at the point 1, 3, 4. And for R, we'll go ahead and just let t be equal to 1. So for point R, we'll just take our parameter t to be 1. And then x is equal to 1 plus 1, which is 2. Y is equal to 3 minus 2 times 1, that's 3 minus 2, which is 1. Z is equal to 4 minus 3 times 1, that's 4 minus 3, or 1. And so R is at that point 2, 1, 1. Now we can form the vector A. So we'll come here now and say A is equal to, again, that's the vector that starts at Q and ends at R. So that's 2 minus 1, or 1. 1 minus 3, or negative 2. 1 minus 4 is negative 3. And the vector B then is the vector that starts at Q and ends at P. So the coordinates of P minus the coordinates of Q. 4 minus 1 is 3, that's the first component. 1 minus 3 is a negative 2, and negative 2 minus 4 is a negative 6. And so let's go ahead and take our cross product now of A and B. That'll be equal to the determinant of this 3 by 3 matrix that has our standard basis vectors across the top. 1, negative 2, negative 3 in the second row, and 3, negative 2, negative 6 in the third row. And so we get, let's see, I times the determinant of the lower right 2 by 2. That's a negative 2 times negative 6 is a positive 12, minus negative 2 times negative 3, which is 6. And then, let's see, minus j. Block out its column and row, the column and row of j, and take the determinant of the remaining 2 by 2. 1 times negative 6 is negative 6. Minus 3 times negative 3, that's minus a negative 9 then. And then let's see, plus k. Block out k's column and row. We have a 2 by 2 left in the lower left corner. 1 times negative 2, that's the main diagonal. That's a negative 2. Minus 3 times negative 2, so that's minus a negative 6. And so we get for a vector here 12 minus 6, or 6 times I, so 6 in the first component. Negative 6 plus 9 is a positive 3 times that negative j. That's going to be a negative 3j. So negative 3 in component form is the second component. And negative 2 plus 6 is 4. So 4 is our third component. All right, and so now I think we're ready to find the distance d. D is equal to the magnitude of that A cross B vector, so the magnitude of 6, negative 3, 4, divided by the magnitude of A, and A is the vector 1, negative 2, negative 3. So in the numerator, it's the square root of 6 squared, which is 36, plus negative 3 squared, which is 9, plus 4 squared is 16, divided by the square root of 1 squared, which is 1, plus negative 2 squared, which is 4, plus negative 3 squared, which is 9 still. So in the numerator we have, let's see, 36 plus 9, that's 45. 45 and 16 takes us up to 61. So square root of 61 in the numerator, and the denominator, 1 plus 4 is 5. 5 plus 9 is 14. So the square root of 61 over the square root of 14, or if you want to write it as one fraction underneath one radical, we have the square root of 61 over 14. 61 over 14 under the radical.